Hello guys, and welcome back to another episode of my Ability System series. In this and the next part we will script all of the functionality for our skill tree so that by the end of those two videos we are able to purchase, upgrade and downgrade spells, as well as dragging around our skill tree and dragging skills from our skill tree onto our hotkey slots. So let's get started. First off, let's open up our W_connection, and first off let's select the line here and set the default alpha to 0.2. So this will be basically the disable state when you haven't learned a spell that you need for another one. Compile and save, then head over to the graph, give it a boolean called active question mark, as well as another variable called forSpell. So the spell that's assigned to this connection, this will be a master skill class, and let's make that editable and expose on spawn. After that we will add one function called activate, and in here we will first get our active, add a branch and see if it's already true. If that's the case we can just return and there's nothing to do for us. But if not, we are going to set active to true. Then we will get the line and set opacity to 0.7. Hook that up, and after that we can just copy over our return node. Right? Compile this, save, and that's it for our W_connection. So let's close it. Then let's go to our blueprints, structures, and to the S_subtree connection, because here we want to add one variable that's called forSpell. And same as in our widget, this will be a master skill class that's going to be passed through when we dynamically generate our connections. Save it, close the subtree connection. After that, let's head back to our widgets folder and let's deal with our skill tree entry widget, this one. Head over to the graph, and first we need a couple of helper functions. First one will be called amount of stages. Make that a pure one with one output that's an integer called out. And what we're going to return is our skill actor. But first we need to get the skill info, break it, get the stages only, and off of our stages array we want to get the length. Then plug that in for the output, and that's it for this function. After that we need another function called update stage text, and that means we need to get our stage text in here and set text. We are going to use a format for this, and the format will be in curly brackets current, then add a slash, and then again in curly brackets max. Figure out what our current and max are. We first need to get our skill actor, then get the current stage index, and because that index is 0 base we need to add 1 to it before we can convert it to a text. To text int, let's expand the options here and uncheck use grouping. Then we can collapse it again and plug it in for the current. Let's copy over that to text node, plug it in for max, but this time the value will simply be our amount of stages function that we just created. Alright, after we set the text, let's return. Apart from our stage text, we also need to update our icon, so let's make a separate function for that, update icon. In here let's get the skill icon and set brush from texture. Afterwards we can return, but we need to figure out the texture first. So let's get our skill actor here, get the current stage index, and let's check whether that is less than 0. So if we haven't learned that spell yet, let's use a select node for that. Then right click the return value and change the pin type to a texture 2D reference, because then we can plug it in for our texture. So if it's true, that means we haven't learned our spell, so we can just grab the default icon from our skill info, get the skill info, break it, and let's only check the icon, then connect it to true. For false, we want to use another select node, and this time the index will be that our current stage that we need to break, and then that the override icon is valid. Connect the is valid to the index. If it's true, so we have an override icon, then we will connect that to true, and if not, we can just grab the default icon from our skill info. Compile and save that function, and we can close it. Before we can proceed in here, there are a few other classes that we need to deal with. For example, our BP master skill. So let's go to skill actors, master skill, and let's duplicate our get current stage and just call it next stage. We will also get one of our stages, but this time not directly from the current stage index. Instead, we want to add 1 to this and then clamp this value. Minimum will be 0 and the maximum is the last index of our stages array. Alright. Plug in that return value for the get node, compile, save, close the master skill. Then let's go to our components and to the bpc underscore skill tree. First off, we need a helper function here called canUpgrade spell ? This needs one input, which is a master skill reference. We can just call spell or skill, whatever you like. And it will have one output, which is a boolean just called out ? Let's also add a local variable just called local bool, and this should be true by default. Compile and save. And there are a couple of conditions that have to be met in order to be able to upgrade a spell. So let's already add a branch, and off of that condition let's search for an AND statement, because we've got multiple conditions. In fact, we will have 3, so let's add 1 pin. The first condition will be that we've got enough skill points left, so let's just grab the skill points, get it, and check whether it's greater than 0. We have to check for the player's levels, so let's get the player character, get current level, and we want to see whether that's greater or equal to the required level for the next stage. So here we grab our spell, get the next stage, break the skill stage, and connect the required level, then plug that in for the second condition. Finally, the third one will be that the current index of that spell is less than the last index of the stages array. So let's get the skill info, break it, let's check for the stages, and get the last index. Plug that in for our comparison here, and then connect it to the third condition for our AND statement. Compile and save. If that is not the case, we can just directly return with false. If it's true, we also have to check for another thing, and that is that all of the required skills were already learned by the player. So we want to run a for each loop with break off of those. And once it's completed, we can return with our local bool. Then off of our array element, we'll call player learned spell, add an if statement, connect that to the loop body. If we learned that spell, everything is fine and we can go on with the next one. If not, we need to set the local bool to false and then break out of our loop. Compile and save this function. Then we need another function called skill on hotkey ? This will be a pure function as well. It will have one input, which will be the skill, so a master skill reference called skill. And it will have two inputs. First one will be a boolean called out ? and the second one will be the hotkey if we found one. So that will be a w_skill hotkey reference. First off, let's promote our inSkill to a local variable called local skill. And we also need a couple of other local variables. First, a local out, that will just be a boolean, and a local hotkey, which will again be a w_skill hotkey reference. So after we promoted our spell, let's get our player character, off of him get the main widget, then get the all hotkey slots, and let's run a for each loop with break again. Then for every element we want to get the assigned spell and first check whether there even is one, so just an is valid check. And if it is valid, we can go into another branch and check whether that assigned spell equals the local skill that we're looking for. If that is true, we can set the local out to true, set the local hotkey to the current array element, and then break out of our loop. And once this loop is completed, we simply return with both our local out and local hotkey. Okay, compile and save this. That's it for our functions. So let's close both of them. Go to the event graph, and here we want to add a custom event called upgrade spell. This will have two inputs. First one will be a master skill reference, just called skill actor. And the second one will be the entry widget in the skill tree. So that will be a skill tree entry reference. Okay. Copy that upgrade spell event, paste it, and call it downgrade spell. We won't implement those in this episode, but just have them created. So now we can close our BPC skill tree and go back to our skill tree entry, because here we want to add another function called update upgrade box. What we want to do here is first get our subtree, get its main tree, get the skill tree component of this, and we will call a function can upgrade spell. The inSpell will just be our skill actor, and then we will add a branch off of our out boolean. If it's true, means we can upgrade our spells, so we want to get our plus button, set visibility of this one to visible, get our minus button, and set visibility to hidden. Then get our upgrade box, set visibility to self hit test. And now let's get our skill actor, get the current stage index, and let's check whether that is greater or equal to 1. If that is the case, means we are also able to downgrade the spell, so we need to show our minus button. So let's get it and set visibility to visible. If the current stage index is not greater or equal to 1, then we want to set color and opacity of this widget to white with an alpha of 1. Okay. If we cannot upgrade the spell, we first want to get our plus button and hide it, so set visibility to hidden. Then let's copy over our skill actor, current stage index, and the branch. Paste that here, because we need to do that comparison here as well. If it's true, we want to get our minus button, set visibility to visible, then get our box, so the upgrade box, set visibility to self hit test, and finally copy over our set color and opacity node and paste it directly here. Okay. However, if this condition here is false, we want to grab our skill tree, just copy that over again, and call player learned spell for our skill class, and add another if statement for that we will connect to the false statement from before. If this is true, again we want to set color and opacity to white with an alpha of 1, as well as setting our upgrade box to hidden, so set visibility to hidden. But if it's false, we will grab our set color and opacity node, paste it for the false, and this time we will lower the alpha to 0.3, then copy over our upgrade box and set visibility, and we will also set it to hidden. If you want to, of course, you can also just connect this execution pin to the set visibility node from before, remove the other one and move that in the middle here. Alright, file save, that's it for this function. In our event graph, we will add a custom event called onSpellLearned. And what this will simply do is set the spell learned to true, get the skill icon, and set color and opacity to a white with an alpha of 1. Then let's select our minus button, add an onClicked, do the same thing for our plus button, swap those. And here we want to call those two events that we just created in our skill tree component, but first we need to get it. So let's get the subtree, main tree, and then skill tree. And for our plus button, we will call upgrade spell. Skill actor will be our skill actor, and the entry widget will just be self. Then we can copy all of the variables, paste them, and off of our skill tree call downgrade spell, and connect the variables again. Okay. After that, let's look for some free room, and we will implement the event on construct, or just event construct. And what we need to do here is grab our skill class and check whether that is valid. Add an if statement, only if it's true we need to do something. And if it's true, we want to spawn an actor from class. Class will be the skill class, so let's just copy that over. Split the spawn transform, leave everything at the defaults. The collision handling override will be always spawn ignore collisions. And we need to get a player reference, so let's just copy over our skill tree, because in that skill tree we've got a player character reference that is set, so we can connect this. Then we can set our skill actor to that return value, and afterwards update the stage text, update the icon, and update the upgrade box. Right? File save. Let's close the skill tree entry widget for this episode. Let's proceed with the default subtree, or the w_subtree. Head over to the graph, and we need a function here called generate content. And just so I don't forget it, I'll just call this function on event construct. So this function will be responsible for taking in the content that's supposed to be in this subtree and dynamically generate it. So I'll show you how you can do this. First off, let's get our canvas and clear this, just in case there's anything in there. And do the same thing for our skill entries and the connections. So we will clear both of those arrays. Before we can proceed to generate the content. To do that, let's get our content and break this. And you will see that we've got two different types of contents. First of our skills, then the connections. We'll run a for each loop for both of those. So let's start with skills for each loop. And for each skill entry, we need to create the associated widget. So create widget. And this will be a skill tree entry. It's asking for a subtree, so that will just be self. And to get our skill class, let's move that aside and get our array element, break it, and then just connect the spell class. Drag in our skill entries array and add to it, then connect the return value. Now we can get our canvas and call add child to canvas, content being the return value. If you hover over that return value here, you'll see that this is a canvas panel slot reference, which means we can access size, position, and so on. So just off of this, set position, and then connect the position from our break node. Then we will set z order to 2. And another thing that you need to do if you generate those dynamically is setting auto size to true. So that's it for all of the skills in the skill tree, but we also need to deal with our connections. So run a for each loop again, and we will execute this on completed of our first one. And here again we want to create a widget. This time it will be a w_connection, break the array element and connect the for spell. Then grab our connections array and add to it the return value. Copy over our add child to canvas node from before, and again plug in the return value. Now off of the return value here we want to set position as well as size. Both of those will come from our subtree connection, so position and size. Now to apply our transform here, we need to get the widget itself, so the return value of our create node, and set render transform. Then hook that up to the execution and afterwards to the transform of our structure. And once both of those loops have been completed, we can simply return. Okay, compile, save, and that's everything for our w_subtree. So we can close it. Let's go to our w_main tree, to the graph, and let's just add one custom event here that we will call on category clicked. It will have one input, which will be an integer called index, and we won't implement it in this episode, so we can just close it again, but we will need that in our w_tree category. So let's open that up, go to the graph, and on construct, first off, we will get our category name, set the text of this, and just plug in our category text variable. Then we'll select a button and implement the onClicked, because then we'll just get our main tree reference and call our onCategoryClicked event that we just created, the index being our own index variable. Now let's select our category button once again and implement the onHovered and onUnhovered. When we hover over this, let's get our category name, and we want to set color and opacity. Then split this, and I'll just enter a hex linear code here. This one will be D5, D5, D5FF. Then for the onUnhovered, we want to grab our selected boolean and add an if statement. And only if it's false, we want to execute something, because then we can copy over our category name and set color and opacity. But this time it will be a much darker color. So 666 A6 AFF will be the hex linear code for me, and hit OK. Then we want to add one function in here called change state with one input called selected, question mark. One thing that we need to check is that the selected is not equal to our current selected state, because that would mean we don't have to do anything. Add an if statement. If it's false, we can simply return. But if not, we have to do something. First off, we want to set selected to our input, then grab our category name, set color and opacity, split this again, and we want to select a color here based on our selected boolean. So if we are selected, that will just be white with an alpha of 1, and if not, I'll use the hex linear code from before, so 666 A6AFF, and then hit OK. Last thing to do is getting our category button, and set is enabled to the exact opposite of whatever selected is. So if it is selected, we do not need to be able to click it again. So just grab a not boolean and hook that up into the in is enabled. Copy over the return node from the else path, paste it, and compile, save. That's it for the tree category. And actually that's it for this entire video. I hope you liked it, and I'll see you in the next one when we'll complete the functionality for our skill tree.